Hello all, welcome to the video lecture series for the subject operating system. Now I'm going to give you the introduction for demand paging and paging followed by the page fault, right? So let me directly get into the topic. What is demand paging? Like, demand paging is a technique, right, which is used in virtual memory system where the pages enter main memory only when requested by the CPU. That is a point here, right? So basically, if you want to understand what is demand paging, then we need to know what is a paging in operating system. See, paging is actually a management scheme, right, which is eliminates the need for contiguous allocation of physical memory, right? The process of this memory allocation in contiguous, that is fixed and variable, we are going to say that. Now, this is a paging which is used effectively in operating system for the effective use of memory management. Let's say this process of retrieving a processes in the form of pages from secondary storage into main memory, right? So whenever the CPU is requesting a page, the paging is doing this particular process when the requested string or a page is not available in the main memory, right? So the basic purpose of paging is to separate each procedure into pages, and additionally frames will be used to split the main memory in order to retrieve and access the purpose of using this, right? Basically here one more point I need to add. The paging physical memory is divided into two parts, right? One is fixed size blocks called page frames, right? Another one is, we used to call it as a logical pages, right? When the process requested in the memory, the operating system allocates one or more page frames to the process and maps that process into logical pages. This is actually the paging which is used for a memory management unit. So let me take you to the what is a page demand paging, right? So whenever CPU is requested, right? So the technique is used when the virtual memory, that is VM stands for virtual memory, where pages enter into main memory only when requested by the CPU, or else these pages will not be available in that. That is, we can call it as recently used, most recently used, or as less recently used. We are going to see that the demand paging technique is operating system loads only the necessary pages in the main memory, and if it is not necessary, it will be swapped back to the secondary memory, so based on the needs, right? The operating system always loads the request pages from the disk into memory and updates the page table accordingly. This is how it is doing. So let me draw a simple diagram so that you will understand how this page is actually and the demand page is actually working. Let's say, for example, the CPU is here, right? The CPU is requesting, the CPU is actually requesting load M. The name of that page is M. Okay, the CPU is requested here. So I'm using different prints so that you can understand clearly. Now it is requesting, number one, we used to call it as a reference string. The string has been referenced. The name of the string is M. So now we have a page table here, right? So the page table doesn't find this M here. That means the main memory doesn't have this. So it will mention it as I. I stands for invalid, right? It is invalid. So whenever the requested page is not there, immediately it will send a trap. That is number two. It will send a trap. Trap in the sense it is a sequence of message which is communicated with operating system. This is OS, for example. It is communicated with the operating system. Whichever page is not available, and it is very serious because it is requested by the CPU. What this operating system will do is number three. This is number three. It will send a pages on backing store. It will request the secondary disk, right? It will request a secondary disk and it will request a backing store. Backing store. Now the backing store will look for this particular thing. Say for example, the M is available somewhere here in the storage in the secondary disk. That is the secondary disk. This is secondary memory. Okay, so it is somewhere available there and it will brought into the main memory. Say for example, So this is a free frame. This is free frame where this M can be brought into it. So we used to call this as a physical memory, and we used to call this physical as a main memory. Okay, now the secondary memory, and it is bringing into this process. This is number 4. Number 4 is what? Bring in missing page. So the page is missing here. It is strap is communicated to operating system, and it is communicated to SM, that is secondary memory, and again it is brought into the free frame. Wherever it is free, it is brought in. If it is not free, then we used to get into the page replacement algorithm, right? That is our future topic. I'm going to teach that too. So here there is a 4. Number 4 is bring in missing page. So bring in missing page. So here it is a free frame. So the load number M, that is frame number, page name called M has been replaced. So here one that is getting into the page, that is in the physical memory, main memory, it will update the page 2, right? So what it will do, it will reset the page. Say initially the page is I, because M is requested by the CPU. M is actually requested by the CPU, and M is not there in the page. That means it is not there in the physical memory, that is main memory. So it will reset the page. What is the meaning of resetting is, it will update the page I into V. I'll tell you what is that V. So this is number 4, right? So sorry, it is number 5. So now the page, this is a page table, right? This is a page table. It will be replaced. Now it is getting into this, but M has been taken into this place. The page is updated with I initially. Now the page will be updated with V. So V stands for valid. Okay, I hope you understand how exactly it is working. Right now the page has been replaced. This, whenever in future M is called, if it is there in the main memory, it will be responding immediately. So last thing is, the resetted instruction will be communicated to the CPU, right? This is number 6. What is that? Reset instruction. Reset instruction. What instruction has been reset here? The page has been reset with this valid. So valid in the sense, the requested page has been brought into the page reference, and it is available in the physical memory, that is main memory, and the CPU can get process into it, right? So this is how actually this particular demand paging, and we used to call it as page fault, right? What is page fault? Let me tell you. Page fault is nothing but whenever the CPU is requesting the page and it is not available in the page table, that means it is not available in the main memory, then this process will be adopted. So whatever I have been explaining about how this is requesting the OS, and OS getting into secondary memory and then to primary memory and then resetting it. This is how this particular page fault works. I hope you understand this video. Thank you.